Hey everyone, so I'm finally ready to give you a tour of my EMPro simulations. As you can see, I've got my frustum here with top and bottom spherical end caps. It's filled with air and it has an aperture in the side. This frustum has a bottom radius of 4.4 inches, a top radius of 1.4 inches, and the height is about 8.2 inches. This waveguide is a half guide wavelength, and I'm using the plane wave simulation here, which is a lot better than the coax, which I'll talk about later. I've got a stub tuner in here that I've been trying to play with to minimize the reflection coefficient. Hasn't been working out so far, but I just started that today. Notice I've got these internal cuts on the side here because right now the plan is to make the waveguide out of a single solid block of aluminum, just for accuracy purposes. And then also we want to make this frustum out of a solid block of aluminum with just a large 9-inch diameter, or a little bit bigger than that, slug of aluminum. Cut off a few slices for the top and bottom caps. I'll do a tour of my SolidWorks file and go through more of the manufacturing thought process I've got going right now. As far as the reflection coefficient goes, right now it's about minus 20 dB minimum. The bandwidth is a few megahertz, which is it's getting better every time, but it's not quite where I'd like it to be. On the visualization side, looks like we've got a TE013 mode, which is nice. The resolution isn't quite there, but that doesn't really affect the S11 or S11 parameters as much. It is kind of cool to watch this wave come in here. You can animate, see that. It's definitely some black magic going on in this region. Also, you could check out the H field. It is also pretty interesting. The aperture always has really high concentrations of H field, which I find kind of fascinating. Also to note that this magnitude here is not the actual magnitude. I mean, it's got a 1 watt standard input, but this is not the center frequency, so I don't think that this is accurate. But yeah, so, and then about that coax, I've done a lot of these files, as you can see. This one in particular, oh, this is still copper. Well, I haven't done a coax with aluminum yet, but the copper one's matched up, so I'm assuming the aluminums will match up. The problem is this coax line is so long, and you do a plane wave through here, that the computation of that whole mesh on the inside there just takes forever. So this simulation will last maybe 10 hours, and I don't have time for that. But it seemed to correlate pretty well with what I was doing, or with the plane wave simulations. So that makes me happy. I'll probably come back to this once I'm done fiddling with the plane wave simulation and try to get this one to match that one again. But yeah, I'll do another video of my SolidWorks file and talk through that process. But if you guys have any questions or comments, feel free to let me know. Thanks for watching.